Okay, Mrs. Raposa here again. Let's do the second part of the 8.4 notes and get into some good stuff with the trig identities. Okay, so we obtained some identities just by dividing the Pythagorean identity right here, sine squared plus cosine squared equals 1. We divided it by cosine squared and sine squared to come up with identities. Now we're just going to do some subtraction. So if 1 is equal to sine squared plus cosine squared, then all I really need to do is subtract cosine squared from both sides of this equation. This will cancel, subtract it from this side of the equation, and I'll end up with 1 minus the cosine squared. That's going to equal sine squared theta. And if I subtract sine squared from both sides, subtract sine squared theta from this side and from this side, this goes away, end up with 1 minus sine squared theta. That equals cosine squared theta. So here's two additional identities. I just want to draw your attention to sometimes you see subtraction done in a reverse order, and you're like, what does that mean? Just so you know, I'm going to put it down the bottom, well, maybe at the top. So for instance, if 10 minus 3 is equal to 7, let me put it over here. If 10 minus 3 equals 7, which is true, if I do the subtraction in the reverse order, so 3 minus 10, that's going to be the opposite of 7. So just keep that in mind. So sometimes you'll see, oh, it's not 1 minus cosine squared, it's cosine squared minus 1. That would just equal the opposite of sine squared theta. That's all. Doing subtraction in the reverse order just gives you the opposite of what you had before. Okay, remember that this identity was what we obtained from this identity just by dividing everything by the cosine squared of theta in the other video. So again, we're going to use some subtraction. If tangent squared plus 1 is equal to secant squared of theta, then all I'm going to have to do is subtract 1 from both sides, and I end up with secant squared theta minus 1 is equal to tangent squared theta. Another one, if tangent squared plus 1 is equal to secant squared, if I subtract tangent squared from each side of the equation, this goes away. I end up with secant squared minus tangent squared theta is equal to 1. And it's really hard to remember all of these, but if you remember this one, and you know you can divide by cosine squared or divide by sine squared to obtain the other two, and then just do some subtraction, you get all the other identities. And more subtraction, for example, 3. Remember, this is what we obtained by dividing the Pythagorean identity by sine squared theta. And just do some subtraction. What does cosecant squared theta minus 1 equal? Just subtract 1 from each side of this equation and you get cotangent squared theta. And what does cosecant squared theta minus cotangent squared theta equal? Well, it comes from this. Just subtract cosecant squared theta, subtract cotangent squared from both sides. This cancels, and you end up with cosecant squared theta minus cotangent squared theta equals 1. Okay, so now let's get to the fun stuff. Let's simplify some trigonometric expressions. Let's take a look at example 4a. I'm going to try to zoom in here so you can see a little better. So 4a says tangent theta times cosine theta. Remember, theta is just some angle measure, any angle measure at all. Let's express tangent as sine over cosine for this one. And when we do that, we're going to multiply it by cosine theta. I can put this over 1 if I want to. That ends up with sine theta times cosine theta over cosine theta times 1. These are going to cancel. So I end up with sine theta divided by 1, better known as just sine theta. So this simplifies to just sine theta. Cosine of 90 degrees minus a. Remember, this is one of the cofunctions. 90 minus a, the complementary angles that add up to 90. Sine and cosine are cofunctions, so this is just going to be the sine of a. To simplify, so whatever angle measure that is. You can go back and take a look at our cofunction rules. Okay, for the next example, it's not really the complements. Pi over 2, that radians, that is 90 degrees. Let me just zoom in a little bit. That is 90 degrees. So this kind of is like the complement reversed. So 90 minus theta, or alpha, or 90 minus a, that's not the same thing as a minus 90. Remember I said that 90 minus a is the opposite of a minus 90. That's kind of what we got going on here. Theta minus pi over 2, that's the exact opposite of pi over 2 minus theta. So I'm going to write this as tangent of the opposite of pi over 2 minus theta. This one's a little tricky. So I'm going to have to use two rules. One of them is going to be the opposites theorem, which is right here, the opposite. So the tangent of the opposite of an angle measure is the opposite of the tangent of that angle measure. So let's use that first. The tangent of the opposite of pi over 2 minus theta, that's equal to the opposite of the tangent of pi over 2 minus theta. So let's write that down. So I use that rule first, opposites. Now I can use the cofunction rules. The tangent of the complement of theta, 90 degrees minus theta, the complement of that, the not complementary angle, the cofunction of the tangent is the cotangent. So I'm going to have that this is equal to, this part is equal to the cotangent of pi over 2, the cotangent of theta. The complement of this is going to be just theta, but it's the opposite of that. So I end up with the opposite of the cotangent theta. So I used two rules. I used the opposites theorem, and then I also used cofunction relationships for this one. Opposites theorem and cofunction relationships. Okay, let's take a look at the next one, D. 1 minus sine theta times 1 plus sine theta. This is just a matter of first, outer, inner, and last. 1 times 1, 1 times sine theta, or sine x, and then distribute the negative sine x minus sine of x times 1, and negative sine of x times positive sine of x. That's going to be negative sine squared. Oh, you can't see what I'm writing. Oops. So negative sine squared of x. So positive sine of x and negative sine of x, they end up going away. So I end up with 1 minus the sine squared of x. Hey, this looks like the Pythagorean identity, something with cosine squared plus sine squared equals 1. So going back to the Pythagorean identity, all I really need to do to get 1 minus sine squared of x is subtract, oh, it's backwards. Yeah, 1 minus sine squared, it's not backwards. So 1 minus sine squared, subtract sine squared from both of these, and I'm going to end up with cosine squared of x. So that simplifies to that. Okay, let's take a look at sine squared minus 1. That's this. So the next example, sine squared minus 1, that's reverse order of 1 minus sine squared. Remember, 1 minus sine squared is cosine squared. So if I reverse these, sine squared minus 1, that's going to be the opposite of cosine squared. The opposite of 1 minus sine squared x. So it's the opposite of cosine squared of x. Negative cosine squared of x. Let's take a look at the next one. Again, just do some multiplication. First, outer, inner, and last when you multiply two binomials. So secant times itself, that's secant squared theta. Secant theta times 1. And then we're going to have negative 1 times secant theta. Oh, I put sine. I meant to put secant. Just kidding. So secant times secant times 1, negative 1 times secant theta. And then we're going to have negative 1 times 1. And again, these cancel out. And I just left with the secant squared of theta minus 1. And let's see which one that looks like. Go back to our identities. Oh, it's on this page. I'm going to find what page it's on. So secant squared theta minus 1, that's right here. Secant squared theta minus 1 is tangent squared theta. That's what that simplifies to. Okay. Let's take a look at tangent times cotangent. Whenever I see two things being multiplied like this, I try to write them as a fraction, like tangent sine over cosine. Tangent, that's tangent of A, that's going to be sine over cosine. So sine of A over cosine of A. And remember, cotangent is just a reciprocal of this. That will be cosine over sine. And so what ends up happening is sine of A over sine of A, those cancel. This cancels, I'm just left with 1. That's not the only way to do this one. You could have also done it this way. Tangent of A times 1 over the tangent of A, because that's the reciprocal of tangent. And this will still give you 1. Tangent over tangent. Either way works. So let's take a look at this one. Cotangent times sine. Again, I like to use the fractions if I possibly can, because things usually cancel out when I have fractions. Cotangent, I'm going to write that as cotangent is the reciprocal. Cotangent is cosine over sine. So cosine of y over sine of y. And then multiply it by the sine of y. And as you can see, when I put this over 1, sine over sine is going to cancel, and I'm just left with cosine over 1, so it's equal to the cosine of y. Okay, our last example is just cotangent squared of x minus the cosecant squared of x. And if you go back to example 3 that we did, we have an equation that relates cotangent squared, cosecant squared, and 1. And it's this one right here. Cosecant squared minus cotangent squared is 1. But this one's backwards, as you can see. It's backwards. So it's not cotangent, it's not cosecant minus cosecant squared minus cotangent squared. This is cotangent squared minus cosecant squared. So like I said, this will be the opposite of 1. This is the opposite of cosecant squared of x minus cotangent squared of x. And that'll just give me the opposite of 1. So it's negative 1. And that concludes the lesson.